Using quantum-inspired computing to discover an improving catalyst for clean hydrogen. Let's start this. Researchers from the University of Toronto, Faculty of Applied Science and Engineering, and developed a new way to searching through the chemical space for materials with desirable properties. The technique has resulted in the promising new catalyst material that could help lower the cost of producing clean hydrogen. Discovery represents an important step towards more sustainable ways to storing energy, including from renewable but intermediate sources such as solar and wind power. Scaling up the production of a what we call green and hydrogen is a priority for the researchers around the world because it offers a carbon-free ways to store electricity from the source, says as by the sergeant and senior author on a new paper published in a Matter. This will provide proof of concept for a new approach to overcoming one of the key remaining colleagues challenges, which is the lack of the highly active catalyst materials to speed up the critical reactions. And today, nearly all the commercial hydrogen is produced from the natural gas, and the process produces carbon dioxide as a bihybrid. And if the carbon dioxide is vented to the atmosphere, the product is known as a gray hydrogen. And but if the carbon dioxide is captured and stored, it is called as a blue hydrogen. And by contrast, green hydrogen is a carbon-free method that uses a device known as electrolyzers to split the water into hydrogen to oxygen atoms. Yeah, and the hydrogen can later be burned or reacted in a fuel cell to regenerate the electricity. However, the low efficiency of available electrolyzers mean that most of the energy in the water splitting step is wasted as a heat and rather than being captured in the hydrogen. Researchers around the world are racing to find the better catalyst material that can improve the efficiency, but because each potential catalyst material can be made of several different chemical elements combined in a variety of ways, the number of the possible uh, permutations quickly becomes overwhelming. One way to do is to the human intuitions by researching what material other groups have been made and they're trying something similar, but that's pretty slow. And that's it is one of the co-lead author and to find out through the team turn to the emerging field of the quantum inspired computing and also the digital annealer is a hybrid unique hardware and software design highly efficient of solving combinatorial optimization problem.